Section 8.5 is titled Factoring Special Cases. By the end of this lesson, you want to be able to factor perfect square trinomials, and also you want to be able to factor the difference of squares. So let's first talk about a perfect square trinomial. A perfect square trinomial is a trinomial that's going to be factored into two identical parentheses. So we have a squared plus 2ab plus b squared. All this means is that the first number is a perfect square, the back term is a perfect square, and the middle term is 2 times a times b. It can be factored then into two identical parentheses, a plus b times a plus b. And remember that that's what a plus b squared is. We also have the option where the middle term is negative, so we still have a perfect square up front for our first term and a perfect square in the back. The middle term is now the multiplication of 2 times a times b, but it's negative. So the two identical binomials that we factor are a minus b times a minus b. So let's look at some examples. Factor each expression. First, I'm going to verify that it is a perfect square trinomial. The front term is x squared. Well, that's x times x. The back term is 16. That's 4 times 4. So when I factor this into the two identical parentheses, it's going to be x plus 4, x plus 4. Notice that the middle term gives us 4x and 4x for our 8x. Because they are identical, you could write them as x plus 4 quantity squared. Either answer is acceptable on the left or the right. Number 2, again, we have a perfect square trinomial. We have a first term that's a perfect square, n times n. We have a back term that's a perfect square, 8 times 8. And we have a middle term that's 2 times n times 8. 2 times n times 8 would be 16n. Notice it is subtraction, so this time when we fill in, whoops, and it's an n, it's going to be n minus 8, n minus 8. And again, you can write that as n minus 8 quantity squared. The 8 is coming from the square root of 64, just as the 4s came from the square root of 16. This only works on perfect square trinomials when your two factored binomials will be identical. Okay, if you want to pause the video and try 3 and 4 on your own. Again, we do have a perfect square. This is n times n. This is 8 times 8. And this is 2 times 8 times n. Remember, it's 2 times a times b. So that gives you 16n. This problem is actually just like problem 2, except it's a plus sign. So it's going to be n plus 8 times n plus 8, or n plus 8 quantity squared. On number 4, we have m times m. We have 3 times 3. This is 2 times m times 3, 6m. So it is a perfect square trinomial, m minus 3 times m minus 3. And you can write it as a quantity squared. We have x squared plus 24x plus 144. Might have to think for a second about what the square root of 144 is, or what number times itself is 144. Hopefully you're thinking 12 times 12. So it's going to be x plus 12 times x plus 12, or you can write x plus 12 quantity squared. Now number 6 is a little different because now we have a coefficient in our first term, but that coefficient is a perfect square. So since the coefficient's a perfect square, the variable is a perfect square, this term is still a perfect square. Notice it's 10m times 10m. 49 is 7 times 7. The middle term then needs to be 2 times one of these times one of these. So 2 times 10m times 7. 2 times 10 is 20. 20 times 7 is 140. So you do get that this is a perfect square trinomial. We have to be careful here. Up front, instead of just m times m, now it needs to be 10m times 10m. They both are minus 7s since it's a subtraction sign in the middle. So we get 10m minus 7. Again, if you wanted to double check that the middle term does give you a negative 140m, this is a minus 70m, and this one is a minus 70m. And when you combine those, you do get negative 140m. Remember, again, you can write it as a quantity squared. Okay, 2 more examples, I think. Try this one on your own, number 7. Similar to 6. So 9x squared plus 24x plus 16. All you're thinking about on these type of problems are perfect squares. What's the square root of 9? It's 3. What's the square root of x squared? X. What's the square root of 16? 4. And they're both plus signs. Eight's very different because now we have an m to the 4th. But if you think about it, m to the 4th, actually any even-powered exponent, is going to be a perfect square. This is 8m squared times 8m squared. Remember, a perfect square is something that you can multiply a number times itself to get that number. Then it's a perfect square. In the back, we have n times n. So don't do the problem any differently. It's 8m squared up front and an n in the back. It's an 8m squared up front and an n in the back. 2 subtraction signs. It just looks a little different because we're not used to seeing that 4th power. But it's because we can write that 4th power as something squared. It's m squared squared. So that means it's m squared times m squared. Now let's talk about a difference of squares. A difference of squares occurs when we don't have a trinomial anymore, we have a binomial. But the first term is a perfect square and the back term is a perfect square. We simply write them, 2 binomials that are identical with opposite signs. Now we've actually worked with foiling these type of problems before. We foiled a lot of problems that were identical but the signs were different, and what would happen is we would lose the middle term. So notice in this one there's no middle term. It's just the a squared in the front and the b squared in the back. So x squared minus 36. X squared and 36 are both perfect squares, so the binomials are identical, just the signs are opposite. One's plus and one's minus. Remember what happens here, that gives us a 6x and a minus 6x, and those 2 cancel out. That's why there's no x term in the middle. So for number 10, it's m plus 10 times m minus 10. Notice these cannot be written as something squared. We can't do this because these are not identical. This only works when the 2 binomials are identical, and they're not identical on number 10. So it's just m plus 10 times m minus 10. Number 11, again, don't let the coefficient up front change your thought process. 9x squared, that's 3x and 3x. 4 is 2 times 2, 1 plus, 1 minus. Same thing on 12. We have 25m squared up front, so that's 5m times 5m. In the back, 64 comes from 8 times 8, 1 plus, 1 minus. These are difference of squares. Difference because there's a subtraction sign. We are subtracting 2 perfect squares, so difference of squares. Go ahead and pause the video, try 13 and 14 on your own. Should be 2x plus 7, 2x minus 7. On 14, we have 9m minus 5 or plus 5. It doesn't matter which one you put first. And then 9m minus 5. I typically put my plus sign first, but remember, it doesn't matter. 9 times 9 is 81. 5 times 5 is 25. So the perfect square trinomials, so we'll go back and look at examples 1 through 8. Remember, your two binomials that you factor it into will be identical. The difference of squares, they will also be identical, except the signs are going to be different. One will be plus and one will be minus. And we'll work on worksheet 8.5 in class.